to the man with the plan.
Hello. I don't have a plan. So, I've given variations on this talk before, so I'm recycling a lot of old stuff, but I'm going to try to go quickly through the old stuff, which you guys may or may not have seen. And anyway. So this is kind of what LiveJournal is. I'm not really going to be talking about LiveJournal so much as the stuff that powers LiveJournal behind the scenes. But quickly, it was kind of a hobby project that turned into something that consumed all of my time, which turned into something that I merged with 6apart, and so a lot of technology has come out of it. So that's it in a nutshell. Blogging, forums, social networking. We never really knew what to call it because it just does a lot of stuff. And the cool thing, though, is everything's open source, so go ahead and steal it. We want you to. So stuff we've built as a result over the years, Memcache for distributed caching, our file system, which we'll talk about that a lot more later, Perlbal for lots of crazy HTTP-related Swiss Army knife type stuff, Gearman, which is really cool, and the Shorts, which is kind of like Gearman for job dispatch and stuff, and our Jabber server, which is pretty fun too. So we'll briefly touch on all this stuff after we talk about this mess. So Ben showed a copy of this earlier in his talk yesterday about Box. And he showed the copy from 2005. There's some new stuff in here. Like all this Gearman stuff is kind of new, and our Jabber server interacting with this is new, and our job queue stuff, and I don't know. So we'll kind of explain how that all stuff ties together. But if you're more curious about all these parts, go look at the old presentations, which is down here. And actually, this slide deck is already online. If you want to go download it and browse it now, it's there. So go ahead and interrupt if there's questions that, as I go, and maybe I'll get to it later. So quick, I'll do my old presentation really quickly. I don't want to bore you all with that since it's kind of been repeated several times even throughout the last day. So, and then I'll explain like all of our software and why you should use it because it's awesome and stuff. So, quick scaling history. So I'll kind of talk how LiveJournal went from one server to now who knows how many servers and kind of the major steps along the way. So originally we had one little server, and I'm a wonderful artist, so this is a database and a web server running on the same box. So that's beautiful. So yeah, I don't do presentations, I don't do graphics, so enjoy. So then we had two servers. So we have the little friendly internet talking to the friendly web server, talking to the database. Wonderful. So now we had two single points of failure, two things that could blow up. And we had no hot spares, no cold spares, and the site got slow again. We're like, why is the site slow? Turns out that we don't have enough CPU power on our web nodes. So we need to get some more. No problem. We buy two more. This guy has a public IP. He talks to the internet. These two guys, we were using, I don't know, a dozen different little load balancers, maybe mod proxy or I don't know, we went through a dozen of them. But some software load balancer between those, but only one public IP. If this guy blows up, we just move the IP over here or something, but it never blew up. But we had a plan. And one database. So great. We're a little better off. But now we're I/O bound. Our database is choking the whole site. So we need to get another database. What do? We buy another database, and we introduce Mysql Replication. So the application running on here puts all new stuff up here, which trickles down to here pretty much instantly. Not really, but close enough for blogging. And as long as this guy wasn't more than a second or two behind, we would use it for non-critical stuff like showing blogs to people that weren't the owner of the blog. If you went into actually to do some critical editing or something, you would always get the important one, the actual one. But so that kind of worked. So now we were reading from both. And then we got to like this, where we had 1 billion web servers and a whole bunch of these, and it was just a mess. It was chaos. So now it kind of looks like that, where we picked up some big IP load balancers off Usenet when a bunch of .com companies went bust. And then we had some mod proxies, and I think maybe these guys were actually on the same physical boxes as these, or we changed it over time, but it's not really important. So we had a bunch of those, and then we have the global database where we have one master and just a whole bunch of slaves. It was okay. But it doesn't really work. So I've shown this picture a lot. So we still have this single point of failure, and this little mouse doesn't work. So say you have one box. This is, that stupid thing on the bottom. All right, so say you have this is one database, and this represents say capacity. It's all the way at capacity. So you're doing 200 writes a second and 500 reads a second, and it's maxed out. So you add another one. Now both machines are doing 200 writes a second, and oh look, they have a little bit of capacity. So everything's good, the site is fast. And then you get like this. And do you like how the tops of these boxes aren't even lined up? That's how awesome I am at presentations. So yeah, so eventually you just keep buying more databases, and the incremental benefit goes to 3 reads a second. So yeah, this doesn't work. So, I mean, we were thinking our databases already do RAID, we do backups. Why are we doing database writes for everything a user does to 12 disks? It's just overkill redundancy, and we're wasting time. So this is when we introduced the partitioning into our app, which shards or partitions where you say this user's over here and this user's over here, and as long as you don't need to join between two users, which we didn't do anyway, you only join between tables that represent this user's own data. It's all good. So every user is assigned a cluster number, and cluster has multiple machines, so you still highly available. So it kind of looks like this. Ben showed a picture of this from yesterday where if you want to load somebody's, say, blog or whatever, you figure out where Bob is, and you say, oh, where's Bob? Oh, Bob's user ID 839, and he's on cluster 2. And then you go read from cluster 2, select some crap out, and then you get the really good blog posts, the incomprehensible English LiveJournal speak. So that's pretty much how it works. And some of this stuff's been covered a lot. We don't use auto increment, so the number space, every user has their own number space, so we can easily move users around. So we have this moving harness that we can say, well, this machine has a bunch of inactive users wasting a lot of space, or this machine's really busy on I/O. So we actively move users all around to both balance disk space and to balance I/O. So I have something else. Oh yeah, so every user has a read-only flag and a schema version, so we could do schema upgrades one user at a time, and so we don't ever have to really have a downtime for alter tables or anything. So that's fun details too. So little digression into building a MySQL cluster without actually talking in detail about it. If you have shared storage, like you have a SAN or iSCSI or DRBD or something, which I'll talk about shortly, you could take a pair of two InnoDB machines and turn it into one database that to all your other machines is just one machine, so nothing complicated to think about, but you'll never lose a transaction. So basically you have Heartbeat on there sharing an IP, or moving a Heartbeat, or moving an IP around between the machines, and only making sure one of the machines at a time has the file system mounted, has InnoDB running, and so that works, but not many people want to run MySQL on a SAN. So if you use DRDB, you can have two just commodity machines with crossover gigabit or something between them, and it's DRDB implements this network RAID 1 where you have two block devices on two machines kept in sync over just the network. And so it sits on top of another block device, so you can use whatever existing storage hardware you want, and you run InnoDB on that. And so you can basically turn a machine. So this is kind of, we've been talking about it forever, and there were problems early on. We're starting to play with it more again, but this is kind of the recommended way to make a super, available MySQL thing that works, but it's just two machines, so then you partition out after that. So between this for HA and partitioning out for load balancing, I'll just hand wave the rest of the presentation whenever databases come up and say, there's ways to do it. So, but there's a dozen different ways to do MySQL, load balancing and clustering and stuff, master-slave, master-master, which requires special schemas, DRDB, there's the MySQL cluster, the in-memory product. they're all good and bad in their own ways. So I guess that's a good thing that you have lots of options, but it's also sad because there is no magic bullet. So I'm done talking about MySQL now. So onto our software, which is more fun. So caching, this is basically the memcache intro. You need to cache stuff, so the question is where. You could do it in mod Perl. You could do it in shared memory on a single box. You could do it in MySQL query cache, heap tables. None of them are that great. So we were fighting all the different places we can cache, and we came up with memcached, which a lot of you have heard of, probably using. So you just, wherever there's free memory, you throw up a node that has free memory, and that's basically, the whole key to it is that's a 2-level hash. The client does the first level hashing to find a node or a virtual bucket or somehow select a server to use. And then internally, it's just a dictionary that you use over a network key value pair. So the original version was written in Perl, but it actually in Poe, and it used CPU like crazy. So it was rewritten in C. And I mean, most of our stuff is Perl, but this in particular had to be C. So on to Probal, which from the name was written in Perl. And actually, the original version was written in C# in Mono, because I wanted to learn Mono. I don't know why. But anyway, so then when I renamed the project from Monobal to Perlbal, when I was like, yeah. Anyway. So Perlbal does web load balancing, which was the original point. Now it's also a web server and a whole bunch of other weird things. But so we already had big IPs, whether or not you like Alteon or Junipers or Foundries or whatever. I think they're all the same. Those things are really good for doing just TCP load balancing really fast, or a little bit of like L7 inspection, looking at HTTP headers. But they're pretty much packet level. Sometimes they buffer a little, but you just can't do enough fun, tricky things with them. So it's generally good to have both, something really dumb and fast on the front, and then a really sexy, fun, tricky load balancer like Perlbal next, and then your big, heavy Apache or whatever you want. So we wrote Perlbal. It's fast and smart and manageable and can do some tricks. So we'll go through some of the tricks that Perlbal can do. I guess architecturally, it's a single-threaded, event-based that it uses the Django socket and stuff. Probably going to merge Django socket and Poe and some other stuff now together. Now that there's like 4 or 5 options, we want people to be able to use Poe components from inside Perlbal and Django socket apps. So we kind of have a plan how we're going to merge the two or make them play together, but we just haven't done it. So Perlbal lets you change all the config at runtime. It deals with all the stuff like dead nodes and smart balancing. It has hooks all over the place, so you can make Perlbal do just about anything if you implement the right hooks. So it does persistent connections, of course, both to clients and to backends independently. So a single client isn't tied to a single backend. So if it's sitting there, you can have with Apache, if you have like a persistent client, it's actually holding on to this 70 meg process for like who knows how long. So people say, oh, your persistent timeout has to be really short, like 5 or 10 seconds. But with this, we could just say, you can have your TCP connection open to Perlbal as long as you want. It'd be 10 minutes if you want, because it's all epoll, so it's not inefficient. So we do things like, this is another trick it does, verifies new connections. So when you like start a listening socket in, say Perl, you say IO socket, inet new, listen, and you say 10, that's saying it will accept 10 connections ahead of time. The kernel will do that inside Linux, but your application maybe didn't accept them yet. It didn't accept the socket. So the kernel has the connection, and the 3-way TCP handshake has proceeded, but you're not actually talking to an Apache process yet. Apache's still busy doing a whole bunch of other stuff, and until it finishes somebody else's request and actually gets back and doesn't accept, then the thing is. So we didn't want the connections between Perlbal and the backends thinking they had a connection and writing to it, writing the HTTP request that came from the client, and then just waiting for maybe 250 milliseconds, a second, until that Apache was done. So whenever we open a new connection, to make sure we actually own the thing and we're talking to an Apache right now, we send an options HTTP request, which is this HTTP mode that like nothing really uses, but Apache replies to it really quickly. And so you just say option star, and it says, yeah, I'm Apache, and I can do get and put or something like that. So Perlbal does that, and this was a huge improvement to reducing user visible latency, because whenever before we send any request from Perlbal to a backend, we make sure that we're actually talking to an Apache and not talking to the kernel. So that was fun. Perlbal has multiple queues, high priority, normal priority, and a low priority. So you can say like all bots or something like Google and somebody that's scraping your site or any of this is low priority. They only get a slot to a mod Perl if there's nothing else to do. Likewise with high priority, if you have some like redirect or Ajax thing or something that like always has to like go quickly, but you know it's going to be really cheap on the back end, it's not going to do a database query or something, you can write a selector in Perlbal or by a regex and say that these requests, they always cut the queue, so and to go in the high priority. And this is actually why we made Perlbal, for doing this cooperative large file serving, where we don't want mod Perl to be spoon feeding large JPEGs to users on slow connections, where by slow connections I mean not gigabit speed. A cable modem or a DSL modem is not fast, not compared to your network internally. So if you have some 70 meg mod Perl process sitting there serving bytes to users, you're wasting your resources. So we wanted some event-based app serving it, but we wanted to have protected URLs. We wanted to say you can only look at this picture if you're a friend of me, but we needed Apache to do that because we needed database lookups and look at permission tables and all this stuff. So what we basically wanted was an internal redirect. We wanted the request to come in. I'll show a picture in a second where the request will come in, then we go to mod Perl. Mod Perl says either, no, you don't have access to this, and we send a 403 forbidden, or we reply and we tell Perlbal, okay, you can serve it to them, but it's actually over here. And the client sees no HTTP redirects. So to the client, it's just one resource. There's no secret URLs or anything like that. So it kind of looks like this. Here's the user, their slow connection. They come down with HTTP request. Perlbal then talks to your mod Perl and injects some header into it saying, hey, I'm Perlbal. I have the capability of reproxying. I mean, this is kind of details. And then mod Perl replies and says, okay, it's here or it's here. For if this one fails or times out, you can try this one. And so then Perlbal transparently goes and gets it one of the URLs from wherever you told it. Maybe if this machine was down, it'll fall back to that one and sends it to the user. So the user sees kind of a mix of the headers. They see some of the headers from this guy and some of the HTTP headers from this guy. And as far as the user saw, it was one HTTP request. So I'll show a little bit more about that later when we go into Mogul stuff, which is Mogul, which is an anagram of OMG files. So Mogul. Anyway, so this is our distributed file system. It's open source. A lot of people are using it. It's not really unique, but it's open source. So you can't use Google GFS, so you should use ours. There's also things like Nutch, I guess if you're a Java person. I'm sure a lot of people are using Nutch too. I don't know of anyone, but I have to assume people are. It seems popular. Mogul's been production for a long time, and lots of people are using it to store a hell of a lot more data than we are. People are storing many, many terabytes on tons more machines. So lots of porn sites are using it. So if porn sites are using it, it's got to be good, right? So basically, storing things, we had no good system before. Mogul was like, after we admitted 3 or 4 times that, no, storing it like that sucks too, and no, storing it like that sucks too. And we just tried a whole bunch of things, and we always hated it. And we're like, let's just build one of these spray files all over the place and keep track of it systems. And so at the time, there wasn't really anything that was good. And we thought about it a little and how it would work and keep track of files and re-replicate. And the first version was done on a weekend. It's obviously had a lot more development time than a weekend at this point. But the first version that worked was pretty much done the Friday after the first weekend that it was hacked out. So we like it. It does a hell of a lot of new stuff now. The main idea is that a file belongs to a class, and the class that a file is in dictates what its replication policy is, like what hosts and devices it should be on, the minimum replicas. The system tracks what disks are where, or what files are where, what disks the status is, both what the configured state of the disk is, whether it's up or temporarily down for maintenance or dead, and it also monitors if machines or devices are unreachable, that file systems are still writable, like the kernel didn't remount it read-only. There's a whole lot of stuff that it monitors for you. And it just makes sure that there's always a replica of your file on a different device somewhere on a different host. So if you lose a host, and the host has 16 disks or something, everything is still reachable because it exists somewhere else. So we don't use RAID. We just use lots and lots of SATA disks. And we've actually had several fun emergencies where we ran out of disk space or I/O capacity, and we literally ran up the street to the hardware store with a bike and a bag and got 16 SATA disks and biked to the data center real quick and opened up all these consumer things and just shoved them into normal web servers, because all our web servers had 4 empty SATA bays on the front that we had nothing in. So we just threw them in there and started up the storage node instances on it, and they started being used. So it's pretty fun just to be able to buy really cheap consumer level stuff. So then there's multiple tracker databases. Remember my hand waving from earlier saying that it's okay to make highly available databases, so you can. And big cheap disks, so no RAID. So basically the parts of Mogul, there's clients that want to either put files or get files or delete files or rename files. There's not many operations. Trackers, which are, we used to call it the tracker. It's really like the daemon that controls everything, including replications. But tracker is kind of a bad name. Then the databases, it's originally was MySQL, now it's abstract, so you can in theory use anything. And then the storage nodes, so we'll talk about all these pieces really quick. The clients are just a tiny little text-based protocol. There's lots of libraries. The Perl one uses a tied file handle, so you create a new file and you just write with it. And when you close it, actually look at the return value of close. A lot of people don't. It does matter, especially with this, because all of the magic doesn't happen until you close it. And there's ports to other languages, and in the future we'll probably just use HTTP to the tracker, so you could just upload files with curl, or if you don't want to use a PHP library or something, you could just use every library. Every language has some built-in HTTP stuff. So clients never touch your databases. They only talk to the tracker. The tracker does everything. It watches all the child processes. It does the replication, the deletion, the monitoring of all the nodes. So it talks to the databases, looks where things up, does the load balancing. This is the fun part. This is Mogul FSD, and you just run a couple of those on your network, and it doesn't matter which ones the client talked to. So if these go down too, the clients will reconnect or time out and find another one. And the tracker databases, it was originally MySQL, like I said. Now it does SQLite as part of the test suite. If you have either MySQL or SQLite on your machine, it'll use one or both. Somebody was doing the Postgres and Oracle. They did that a while back, but it was never merged because we didn't have an abstract framework for doing all this stuff. They're probably going to remerge it at some point. We're going to add partitioning in the future, so if you have billions of files, a lot of people have way more files than we do. The actual schema is pretty simple, and we don't store much in the database, so you can have commodity database machines keeping track of pretty much hundreds of millions of files without busting a sweat. So, but we'll probably add partitioning in the future just so we can say we support billions of files without any problems. And so the recommended config is you just have 2 MySQL machines as your master, InnoDB on DRDB. Then you have 2 slaves underneath, one for backups, so you don't have to take down anything while you do snapshots. And then you have a read-only slave that if there's a failover event between the 2 machines on top, at least you have read-only traffic during that 10 or 15 second window. So that's kind of the recommended config. The storage nodes is just anything that speaks HTTP, get, put, delete. So it comes with mogstord, which is just, Perlbal is a library too. So mogstord is just a little wrapper around Perlbal, but it also has another interface on the side that does IO stats, which is how Mogul FSD, the trackers, know how busy the disks are and stuff. And it does some fancy asynchronous IO stuff to make sure that one disk failing doesn't take all of your IO threads and make them all busy. So mogstord is kind of the recommended one to use. A lot of people, they really like their Apache and their mod dav, so it works with that. A lot of people like Lighty, so it works with that. So pick whatever. The files just are stored on a file system, not in the database or anything, so you can use XFS or Riser or X3 or whatever you want. But the cool thing about having them on the disk is then we just call send file on them and do 0 copy IOs right to the client, and we get all the caching we get for free from the operating system, and it's really fast. So this is how a picture is served on LiveJournal or Vox or whatever. The client comes in through the internet to the big IPs, goes to a Perl val. We talked about this whole little path earlier. Goes to a mod Perl. The mod Perl maybe checks permissions to see, is this a friend of yours? Does your friend allow you to see this picture? If so, it asks the tracker, where is this file? The tracker says, oh, it's, maybe it's here and it's here or something like that. Replies from mod Perl to Perl val with the 2 locations, and then tries to get it from here and sends back to the user. So again, to the user, it's one request, but internally, maybe also this part was avoided because we went to memcache instead, and maybe this part can use memcache optionally. I mean, you could wire it up however you want, but this is what happens on LiveJournal and Vox. So this part is slow and expensive, and we don't like to do that often, but we finish it like right away. After we reply on this little green arrow here and say all the locations it is, this part, it can take forever. We don't care. It's all event-based here. This deals with tons of packets. It doesn't matter if the TCP connection's open forever. Likewise, Perl val is event-based. This is event-based. So we just let that go. And the reverse. If you think downloading files is slow, at least in the US, you can't upload at all. I don't know. It's terrible. It's really embarrassing that it takes forever, especially on a phone, like uploading a picture or something. So that can really suck when you're having a mod Perl trying to receive a picture, and maybe your timeout on your Apaches is 5 minutes, and it's taking you 5 minutes to send this like 1 megapixel thing from your phone. So Perl val can, if your file is taking too long or it's too big or something, it can write it out to tempfs, and only when the whole request is in, blast it all the way to the back end. So this kind of saves us on a lot of stuff too. Okay, enough with Perl val for now. I'm going to talk about Gearman, which is really fun, which is an anagram for manager, which is something that dispatches work but doesn't do anything useful itself. So this is kind of our load balancer for function calls rather than HTTP. So I guess I called it a low latency remote function call router. I don't really know. There's probably a better name for this. For a description, let me know. Basically, a client wants a result. It wants to call some function. And so basically, all a function call is some function name, which is just some opaque bytes, and some opaque args, which is maybe a storable or something like that. Anyway, and then there's an optional coalescing value. So if say two callers, 2 mod Perls want the same thing at the same time, that's going to take maybe a couple seconds, maybe a database query or doing some remote web services call to some third party. You don't have to do it twice. First one does it, and the next one later will join in, and they'll connect to the same one that's already outstanding. And when the result finally comes back, it'll be multiplexed to all the callers. So that's Gearman in a nutshell. There's a little binary protocol. We made it with the intention of writing it in C later. We haven't yet because it actually turns out to not use any CPU, but the protocol was designed to be very easy for C clients in the future. So we use it for tons of stuff on LiveJournal at least. Like, we don't want image magic inside of our mod Perls because our mod Perls are already like 70 meg, and we don't want them to be like 2 gig. And if you're resizing some huge JPEG and it's taking the JPEG up to its full size uncompressed or rescale it or do some filter or something, we just do not want that happening in our mod Perls. We want some predictable amount of size memory. Likewise, you can use it for like DBI connection pooling. Ask Bjorn Hansen has combined DBD Gopher, which is pretty new. It's like a remote DBI thing with Gearman. So his application thinks he's using DBI, but it's really using this DBD Gopher proxy driver, which is really talking to Gearman, which is then using DBD Gopher in reverse and doing the DBI. So his application thinks it's just using DBI, so there were like no changes, but he's getting connection pooling and coalescing and stuff for free. Then you can use it to reduce load and improve visibility. So if you know, for instance, now that all your, I don't know, you can log into one of the Gearman servers and say what's going on. You can say, oh, there's 90 processes waiting for this service call or something, that you could see exactly what's going on. And if you want to implement like services internally, it's good for that because all your services can be in different languages. and it's just a really fast protocol to exchange stuff in. So currently we have everything in Perl, but there's no reason you can't do something else. It's also really fun for running code in parallel. We all love Perl threading here, right? Yeah? Perl threading? Yeah. So for instance, if you want to query 10 databases in parallel, you can't really do that right now. I mean, you could start 10 connections and issue the request and kind of hope that they're working on it, but you have to read from them in serial. And the first one may, I don't know, be ready right away. And it just sucks. So with Gearman, you could just issue 10 of them at once and wait on the results all at once. And so it lets you do like threading type stuff. We've even done stuff like shipped serialized subrefs around using bdparse storable, and then ran the code remotely and shipped back the result. So it's kind of trippy. And you could run blocking code from event loops. So if you have like some PO app or Danga socket app like our Jabber server or Perlbal, and we need to do something that we don't want to write asynchronously, because writing asynchronous code is kind of a pain in the ass, we have a Gearman client that runs within an event-based world, ship it off to something else to do it, which is also a good way to spread CPU from these event loop daemons, because an event-based daemon will typically just run on a single CPU. So if you have some expensive stuff to do, ship it off to some Gearman workers. So the pieces of Gearman is there's Gearman D, which is just the dumb router. It's an event loop. Like I said, it's now Perl. Maybe it'll be C. Then we have workers, which just use Gearman worker, which is just a little wrapper around the Gearman client API. I mean, the protocol is the same whether or not you're a worker or a client. It's just the difference of what methods you're calling to the server, saying either I can do something or I would like something done. So the workers register what they can do and do heartbeats and grab jobs, and they're woken up if there's something for them to do. And the clients, likewise, there's two clients on CPAN. Gearman client, which is the normal blocking one that you would use, like, say, for Mud Perl. Then there's the async one that you use from, like, a event-based app. So they submit jobs, and they try to hash onto a specific Gearman D, so it's an optimization for coalescing. Just if two clients have the exact same args and they say that it's okay to coalesce the request. I mean, Gearman doesn't do the coalescing unless you ask for it. So, but if the one you were hashing onto is down, just go ahead and pick another one. It doesn't really matter. It's just an optimization to prevent things being done duplicate. So here's a really, oh, it messed up again. I don't know why. I hate OpenOffice. All the pictures, all the text goes up there. So these are workers, which you can see up here. And these are the Gearman D routers up here. So here's your client, which you can see right there. And so this client wants to say, I want to run function A, and here's the argument. So the client will pick one of the three. Maybe it'll hash onto one optimistically if it's available. And all these workers are just sitting there, little daemons running in little loops. They've registered with all the Gearman Ds what they're able to do. And if they're idle, one of them will wake them up and give them a job, and it'll get done, and it'll get sent back here and routed back there and multiplexed, or there's status packets, so you can say, I'm 5% done or 10% done, or if there's failures, the client will retry. So basically, there's a lot of fun communications that happens between different parts, and you can get events about the status of your job. As far as guarantees, there's none, which is why it's so fast. So don't use this for anything that's important that you actually want to be done. If you want the results and you want to make sure it actually succeeds, stick around and wait for it. Because if you go away and it fails, no one is going to care. There's no policies or conventions or anything in Gearman D. There's the opaque argument name and the opaque args. And other than that, all semantics between what those things mean is all between the endpoints, between the clients and the workers. So the summary is it's very sexy, and especially the coalescing, and you should check it out because it's awesome. And yeah, sorry, unadvertised secret. But I found out, I got mail from Ask and other people recently saying they're using it, and I was like, whoa, you're using that? I've never talked about it. So I guess he just found it in our subversion and started using it. So now I'm officially advertising it. Related to Gearman is the Schwartz, which is kind of a silly name. We just wanted to have a Perl module where we can say use the Schwartz. And we have, it's a stupid movie reference. And we have a boss called Mike Schwartz, and he was sad that nothing's ever been named after him. So now, and he's a manager too. So we have a Perl module called now the Schwartz, which is, it's like Gearman, yeah? And no, it's not an anagram. It's sad. We worked on it really hard. We spent like 2 days trying to think of an anagram. So it's like Gearman in the same thing that there's opaque function name and opaque args, but unlike Gearman, it's not low latency and it's incredibly reliable. And so this is for things where you want a job to be done and you don't want to wait for it because you know it's going to take a while, but you want it to, if there's failures, you define the failure policy and the retry policy and all this stuff, and you can come back later and get the status of it after the fact. So between the Schwartz and Gearman, this is how we deal with all of our things that don't happen inside of Apache. And sometimes we use them both together, which I'll talk about. So this is currently a library. It's not a network service. It probably will be a network service in the future as well. But the basic primitives is you can insert a job. You could grab a job to work on, which is an atomic grab, so things aren't being done multiple times. But you grab it only for a certain amount of time, so if the thing blows up while it's processing, it'll still get done. You can mark a job done. You could temporarily fail a job and make it go in the future, reschedule it. And the cool thing is you can replace one job with one or plus other jobs atomic. So you can say, this job is marked done only if you enqueue these other 10 jobs to be done in its place. So we use that for a ridiculous number of things. Between all these primitives, like any sort of async task can pretty much be mapped onto these. So we use it, one more. The backing store for this is a database. It uses data object driver, which Vox developed. It's their object relational mapper, which does a lot of sexy tricks. So we pretty much just use it for MySQL. The test suite uses SQLite. In theory, it works with Postgres because TypePad uses data object driver, which uses Postgres. So it should work transparently with Postgres. And it's HA. You have a lot of databases. Same thing like Gearman. It picks one of them and maps onto it. And workers go through them all, blah, blah, blah. So we use it for outgoing email. We send millions of emails through a day. Like, we used to use Postfex, and we had a whole bunch of them, and it just kind of sucked. We wrote our own SMTP client that's a Schwartz job, and it's wonderful. And now I think Vox uses it too, Ben. Yeah. So, yeah, it's really fun. And it wasn't like, it's like a page of code. Then our LJ notifications, everything on LJ that happens fires an event, and users could subscribe to any events or wildcards of events. And then people can choose on a subscription that matches how they get notified, where a notification is an email, an SMS, a Jabber alert, a web inbox alert. So basically, one event can be matched by hundreds of thousands of subscriptions, which can then multiply into hundreds of thousands of everything's, SMSs, XMPP messages, etc. So of course, we're not going to do that synchronously with a web request. It would just take forever. So we fire an event into the system, and then asynchronously, we deal with the multiplications of events to subscription matching, including subscription matching per cluster independently, including firing the notification. So this is where we use that replace with primitive, where this can expand from one event that goes into the Schwartz to be done to millions of things to be done afterwards. Use it for pinging external services, which are notoriously slow. You don't really want to do like SOAP and stuff requests from your web app because who knows how slow that other party is going to be. Injection into our Atom stream. What else? Yeah, I don't know. This is just a really small subset of what we use it for lately. Anything that had a custom queuing thing before, we've since ported to this. So we've started using them both in parallel. One project now is doing this, where Gearman has the good property that it's low latency, there's no disks and stuff, and the Schwartz has the property that it's reliable and things will get done. So we're now doing things like putting in the Schwartz first and then using Gearman to kick off a worker so it gets done. So normally if you're polling, this worker library is polling every 1 second or 5 seconds. That's unacceptable latency for a web environment where something maybe should or could get done within a couple milliseconds, but if it doesn't, you absolutely have to have it be done later. It's kind of a weird case. So we'll use Gearman to kick off a Schwartz worker to do it, and we could pass a lot of information in the initial Gearman request to avoid all lookups later on from the Schwartz workers that would have to do multiple queries to the database, like give it the handle or to give it the ID in the database that it'll need. So we've been able to do really low latency plus reliable things by combining these two. I'm probably going to wrap these up somehow into some sort of sexier package where you don't have to know the details of both, but it's promising. Okay, DJabber D is our Jabber server. 5 minutes? Perfect. So it does server to server. It works with Google Talk and all this other stuff. It's event-based, ePoll. I think it's more efficient than any other Jabber server out there as far as memory usage. We've done like 300,000 plus connections on it, and it does things like in between. Jabber is XML based, so in between XML stanzas, which they call them, basically an open tag starts, and when you get closed and you get back to 0, the clients are just sending white space periodically as keep alives. But in between that, you could throw away the XML parser and only. So we have a pool of XML parsers that are shared. So you have 300,000 connections, but most of them are just sitting there idling, sending spaces. So we don't need 300,000 libXML objects around. So we throw them away and have a small pool. And so we're able to be extremely efficient with memory. And so it's all event-based, Django socket. In the future, when we merge with Poe stuff, we'll be able to use Poe components on it. But it uses Gearman. So all the integration with LiveJournal. Basically, the reason we needed our own Jabber servers, we tried to use a couple others, but the only extensibility the other ones offered was maybe authentication, but generally not. So we wanted the little picture, the little avatar in Jabber to be your LiveJournal user pick. We wanted your username and password to be your LiveJournal username and password. We wanted your Jabber roster, your buddy list, to be your LiveJournal friends list. Like, we wanted complete integration with everything on LiveJournal mapped onto Jabber. So there was no Jabber server out there that was extensible in that way. So I dealt with the most painful things in the world, which is the Jabber spec and XML, and we wrote one. So it is like the mod Perl or QPSMTBD or Plagger of Jabber servers. Everything is a hook, and everything actually is an async hook. So you can spend as much time as you want. There's this hook chain that represents all the hooks that will be done for a phase, and everyone could spend a lot of time on it or later defer to the next one, and then it'll eventually fall back to the default implementation. So we use Gearman client async for all this. We're doing like database lookups to find your friends list or to go find your user pick, or the user pick on Jabber, your little icon, can only be like 96 by 96, and on LiveJournal it's 100 by 100. So sometimes we have to image magic down the 100 by 100 picture on LiveJournal down to 96 by 96. So that's using Gearman and image magic and not within djabberd. So I think that's it. Rather than going on to bonus slides, we can spend the 5 minutes on questions. Anyone has any?
日本語での質問もありましたら。
実は宮川さんに懇親会の時に聞けて脅されてたんですが、djabberd のデバッグをする時なんかにダンガソケットが動いていて、デバッグモードにした途端にものすごい勢いでメッセージが流れてくるんですが、どうやってデバッグをしているんでしょうか、もしくは内部状態をどうやって追いかければいいんでしょうか。
So he's using a djabberd implementation with a Django socket, and there's some problems that are occurring somewhere in it. And when he turns on the debugging for the socket, he just gets a ton of messages. Do you have a recommendation on how to debug that combination?
Yeah. Debugging these sort of event-based apps are fun. Especially, we have memory leaks all the time. If you have djabberd has so many, it's so functional, and there's so many closures holding on to stuff. So we've had to do a whole lot of stuff like to debug memory leaks and debug with it's a pain. I wish I had a great answer, but I don't know. We could talk later and about your specific problems, and yeah, we've done a lot of debugging on it. So maybe I could help later.
ちょっと追加します。やはりその問題意識があります。で、もうメモリリークもかなりあったりして、やっぱりイベント系のものはディバッグしにくいですよねっていうところだったんですけども、以上です。あと何か質問ありましたらどうぞ。English questions? Observations?
サーバーアプリの、パフォーマンスチューニングのなんか、テクニックかなんかあれば教えていただきたいんですけど。
Do you have any recommendations or specific techniques that you use for performance tuning for the server-side applications?
For mod Perl stuff in particular, or event-based stuff? No, not really. It's I don't know. You could most of the Perl profilers all suck in their own unique ways, and if they don't crash the thing, So yeah, we've had to do a dozen different things, but there's no good answer. I don't like any of them.
一つの答えはちょっとないんですけども、でやはりパールプロファイラーいろいろ使えるんですけども、やはりそれでも物足りないことがあります。でよくこけることもありますので、やっぱケースバイケースで一つ一つ潰していくしかないです。
I have at times, but I don't think it's that good for Perl stuff. I mean, you could see where you're spending time in C libraries, but not really on Perl stack frames.
Questions? 質問 Comments? 指摘 Anything?
All right. Well, thank you.